Alright, today we are going to learn about real zeros of functions using I. And first thing to remember is, how do you get I? So when you get a square root with a negative, like -1, this would equal I. Or I squared will equal -1. And for an example, we have the square root of -9. Now to solve this, you need to get rid of the negative, which will be I. So you got I square root of 9. And the square root of 9 is pretty easy. It's just 3. And then you'll have 3 multiplied by I, so it'll just have you as 3I. Here's another example of square root -50. Take the I, turn this positive 50, square root of 50. You can simplify that to square root of 25 times 2. And that's easy. Square root of 25 is 5, so you have 5I square root of 2. Now, that was just the easy part. Next, you gotta find the zeros. But before you do that, you need to remember that if A plus BI is a zero of f of x, then A minus BI is also a zero of f of x. So now let's get into an example of x minus 3i times x plus 3i. Now here I just want to identify the zeros, so what would ever make this equation equal 0 would be 3i and -3i. Simply because plug 1 into x, this will be 0 multiplied by whatever, always equals 0. So next example would be f of x equals x minus 5 times x minus square root of 2i multiplied by x plus square root of 2i. Zeros would be 5, because 5 minus 5 is 0. Square root of 2i, same thing. And also negative square root of 2i. So now this stuff is very easy. Now finding zeros that aren't even seen in the equation would be f of x is equal to x minus 1 times x minus 1 plus 2i times x minus 1 plus I. Now the zeros here are, that we can see, are 1 minus 2i, and 1 minus I. But because of that a plus bi and a minus bi, we can see that 1 plus 2i is also a 0, and 1 plus I is 0. How much time was that?